Welcome to the lecture series on object oriented analysis and design. In all these lectures which we have been working on, the essence of object oriented analysis and design has been studied, languages, tools. There are so many other things that are built around just a few handful of concepts. One is polymorphism, the second is inheritance, the third is data encapsulation, plus an object which has a state and a behavior. Just this handful of core concepts made a paradigm possible because it is a different way of thinking about software development. As we progressed, we also understood that object oriented analysis and design is by far the closest to the business dynamics, the way the businesses want to operate. It is not that they do not want to do development, but then a business makes lot of business sense when they talk about operations. Development tends to become quite sublime in that business execution model. So, what we have done is we have come up with this object oriented analysis and design paradigm that makes us do the analysis top down, that is the business driven. However, as we progress, very soon we will start catching up on what are the things that are existing, whether as components, packages, objects, prefabricated, code bases, code segments, and then see how we can put them together to quickly meet the business goal, either the existing goal getting improved or a new goal suddenly emerging. We somehow think that object oriented analysis and design has been very flexible from what we have been talking about as change request. We are now moving very firmly into the area of extensions, building based on the basic building blocks we have, components, and so on and so forth. To cut the long story short, year 2000 we have concluded that there must be a unification in the way we have been talking about identifying objects and modeling them. That unified modeling language UML came from object management group that is made of so many industries, academicians, researchers, and as the technology trend progressed, we simply called it what is called UML became synonymous with object oriented analysis and design. We are not so much concerned about classifying it as whether it is academic, industry, research or whatever. It virtually became synonymous with what is called object oriented analysis and design, and which stood the test of time 20 years, which is a long time for anything that has sustained in the field of software engineering. However, we cannot forget the beginnings which were more in the domain of programming languages, programming paradigms. Till today we are not really talking about OOAD, we are normally talking about a paradigm called object oriented paradigm, of which OOAD forms a very central part. And what we did was we said anything that is based on OOAD is usually called object oriented software engineering. It is a usage, the deployment of a paradigm, object oriented paradigm, which began in the realms of programming, and what we said therefore was that it is necessary to keep alive those languages. I did about 7 languages on 11 features. Smalltalk was picked up as a special case study. The beginnings of the object oriented programming are very much rooted in the understanding of programming, programming paradigms, and the languages that conform to those programming paradigms. Smalltalk was a very nice idea because way back in 1980, that is 4 decades back, they were talking about a simple way of looking at the visual of what is being constructed mapping onto the code directly. It's a very good idea, very powerful idea, very well designed, small single page syntax. It's very easy to understand. Object oriented began to become reasonably simple and appealing to what we normally do. Take a Meccano, build Meccano based on 20-30 components, build about let us say 15 to 20 different artifacts using the same reusable components. So, that brought us into the realms of reuse based software engineering. That became a highlight. We have given several flavors. Now, we understand that it is essential to note that in the world of internet, the moment we move towards internet and internet programming and web, the idea of a thing is very essential, and what we have understood is that in a given organization, applications happen gradually, and we need to understand that unless we integrate the usage of these applications, we are not leveraging the maximum benefits. That is something which is very, very important to understand. So, how to make these applications built from different paradigms, different languages, using different tools, using different teams, working for some time, they are all meant for some other purpose also, but then when we are putting together all these things, how do we make it happen very quickly? How do we make that integration happen very quickly? So, one such idea that brought together this many set of applications which are all there is service oriented architecture. There are two dominant technology options. One is called web services. Web services is something like, we will put one wrapper around the existing application, saying that please do not try to find what exactly is that application doing. What you want, you tell, it will be done by that application and sent back. The result will be sent back automatically. That can happen even now. If you know that a given application is existing in some place, we would have definitely approached that particular place and then said, based on some simple paperwork or whatever, we will get that facility work to solve a problem which is very specifically defined, a task well identified. Now, this will happen automatically, the web servers. So, the facilities can be anywhere, all over the globe. Grid computing is a very good computing model which facilitated this. Limited number of resources, and you know where the resource is, you can access to that. Grid computing stems from distributed solutions, distributed systems. Web services is a service oriented architecture where it can come from within the organization, within the fellow who is owning the facility where that application is there. These are the services that are available. We register it in a particular directory. There is a directory in which that service is registered. So, whoever wants to use that service will simply send based on the directory to this particular facility, get the service done. Makes business sense. The other service oriented architecture, which is right now more dominant, is the cloud computing architecture, promising a phenomenal plasticity. Everything is an object in our world is what we said, and we keep building extensibility, everything is there. So, the cloud computing has three flavors: platform as a service, infrastructure as a service, software as a service. For a start, there are many others which we are talking as a service as we progress. Many things can become as a service. So, we have found some limited success on few critical requirements, namely the scalability, elasticity, plasticity and so on and so forth. However, they have also reached a sort of a summit. We have pushed these two options, technology options, and therefore, we are falling back on the object oriented paradigm, which always said that there can be things anywhere in the distributed system, they can always be there, and all that you need is, when you need a service, please tell what is the kind of a service you are looking, put into what is called an object request broker. That object request broker will flood the net, find out who is offering the service and arrange that the service requester and the service provider have a handshake and then work further. So, that can happen dynamically, that can happen online. The idea was good, and once again the object management group came up with a way of functioning, a way of working together on a single page by defining the specifications for common object request broker architecture CORBA. What did Bettermeyer say? Is a French academic, author and consultant in the field of computer languages. He created the Eiffel programming language and the idea of design by contract. So, we cannot move away from the fact that the core ideas of object oriented stemmed primarily from programming paradigms and the language design. So, we take recourse to understanding what exactly was one of the well known reputed computer scientist and a designer of a language, Eiffel, with a core idea called design by contract. If you have a contractual obligation, it is easy to locate. We all want our software systems to be fast, reliable, easy to use, readable, modular, structured and so on. There is no dispute about it. By saying that we are talking about object oriented programming paradigm, we are not debunking other paradigms, they are also there. We have learnt our lessons very properly. Object oriented programming paradigm gives a cogency of application of those few handful of principles, handful of methods, which are now roughly all merging into what is called a unified modeling language. But these adjectives describe two different sort of qualities. On one side, we are considering such qualities as speed or ease of use, whose presence or absence in a software product may be detected by its users. These properties may be called external quality factors. Other qualities applicable to a software product, such as modular or readable, are internal factors perceptible only to computer professionals. Now, we are talking about only a few factors, not all quality factors. We are not digressing into understanding what are all the quality factors. We know that certain quality factors are external, certain quality factors are internal, who have access to the actual software text. Those of us who are reading the actual software are also looking at the internal factors. Those of us who are not reading the actual software text talk only about the external quality factors. It is very useful to draw a line between what is that contractual obligation by the developer, what is the contractual obligation by the user. It is essential to distinguish between internal and external. There is no hard and fast rule, but there are certain quality factors that are both internal and external. Those we will pick up later, if necessary, in a separate set of lectures maybe. In the end, only external quality factors matter, because that is where the user is impacted. If I use a web browser or live near, if I use a web browser or live near a computer controlled nuclear plant, little do I care whether the source program is readable or modular, if graphics take ages to load or if a wrong input blows up the plant. The point here is that it is not really a serious hair splitting debate between internal and external quality factors that really matters. What is essential to understand is that there is a web browser, there is a software operated nuclear power plant. So, we should understand that the web browser should respond quick, the web browser should not unnecessarily blow up the nuclear plant just by the side of this particular facility. So, therefore, what is it that we have understood is the physical infrastructure is one, the infrastructure which is making the software share so many resources, including the networking provisions, networking equipment, is a different concern. Therefore, we have been talking about very many things as internal, external, but the key to achieving these external factors is the internal ones. For the users to enjoy the visible qualities, the designers and implementers must have applied internal techniques that will ensure hidden qualities. This is what Bettenmeyer said in his wonderful book Object Oriented Software Construction, published by Prentice Hall in 1997. What is the crux of this issue? The crux of this issue is that it is not really blaming blames. It is only to understand that the distinction between what is called knowing the internal and not knowing the internal should be understood carefully. Not knowing the internal is black box kind of an operation, knowing the internal is a white box kind of an operation. So, we are all talking about object oriented, we have been talking about all these things. It depends on the criticality. If we are talking about a very critical facility like a nuclear power plant, we should be very careful about it. So, we have been telling that while all these standards, quality standards are there, depending on the application at hand, we may become a bit more stringent on applying the standards and say that no, this is not simply acceptable, even though it is half a point less, we can't accept. So, the way the standards are being made, these are all very, very intricate concerns in the field of software. Not that we have too many standards, but then we do understand that over the past 5 decades of software development, we are very fortunate that there is adequate number of standards for commonly asked concerns, issues and core defects or the major flaws, failures that we are addressing in the field of software engineering. So, design by contract is a very good idea. That is a contractual obligation, which tells that this is what you are expected to do, this is what you will have to do, go by the contract, then there is no concern. Appears commonsensical, it is not so much of a debate between what is internal, what is external. What we are talking about is the fact that appropriate use of internal and external factors. So, based on this, we created one more idea called business object re-engineering for reuse by Chris Porridge. It is Butterworth Heinemann 2nd edition and by Borough Engineering, copyright by Chris Partridge. 2011 was the most recent one. We soon found that modeling the existing system was not a straightforward case for building an OO model, but that it fell into two groups, reverse engineering and forward engineering. One of the ways in which we were identifying objects was the domain. Say for example, we did this exercise before. If you want to find out whether object oriented analysis and design delivers better in an air traffic control room, please go to the air traffic control room, please observe what is happening there, identify your business objects. One of those time tested object identification and modeling technique is to simply go to the context. The more you get into the context, the more you get into the domain, the more likely you are to find out which are the better objects. You can identify better objects, you can model them well. So, these approaches of identification, object identification were in two categories, reverse engineering, forward engineering. In the reverse engineering, the existing system's business entities are translated into business objects. In most cases, this involves translating the system's computer code straight into a business model. So, this is how we have been talking about, saying that this is what it is happening and is a code that is written. Again, I mentioned earlier on in the lectures on software reuse, if you want to change more than 10% of a code written by somebody, you better start from scratch. So, in the world of reverse engineering, we have been talking about the plenty of code is existing. Please do not try to put service oriented cappings here and there and then go ahead. We need to talk more about either white box or black box. Componentization gives us the best results. So, whenever I see a code base, whenever I see a business context, I would still think that based on that code base, based on the business context, I will go through the full exercise of object identification and modeling, put it in the full set of those 11 things and 9 diagrams, and then go ahead and then talk about a business model. From there it can go into development, it can go into deployment or operations. This idea is effectively called reverse engineering. Forward engineering naturally identifies inaccuracies and artificial constraints in the way the existing system reflected the business. The forward engineering people tell, please do not dig out what is already done. It is there. Using what is already there, we have been experiencing these difficulties. That is also true in a business context. So, everything is fine except the fact that it all depends on what is it that the application is demanding. If it is a nuclear plant, mission criticality, it is the criticality of the application. In the field of systems, we keep telling that as of now, it is not such a risk factor, but as we progress, the same thing that we thought was completely unnecessary may become a very serious risk factor. So, we will have to keep talking about systems reliability. So, over the last 50 years, we have been also bringing in the idea of systems, project management, process and so on. So, forward engineering keeps on telling us, goading us that we have reached this stage, good, bad, right, wrong. We are experiencing these inaccuracies and certain constraints which we think can be done away with. Based on whatever we have been observing, we talked about an improvement path, a progressively improvement path of forward engineering. So, how much you want to do reverse engineering, how much you want to do forward engineering, all these things simply put together is the term re-engineering. It was becoming very obvious that the best of the organizations will have to try this, and re-engineering as a concept was very dominant in 1994. 1994 it was a very dominant idea. They were telling that it is neither reverse engineering nor forward engineering that is going to help us. We do re-engineering for reuse because there are already nice things done. You will have to model it properly and reuse, then it becomes faster. Business Objects by Chris Partridge is a very nice book. The first half of the book is divided into the following 5 parts: our strategy for re-engineering, part B our starting point, part C shifting towards objects, part D shifting to the object paradigm, part E constructing science for business objects. So, this is where I am using this book as a very good illustration for business driven architecture, use case driven architecture, requirements driven architecture. Whichever object we are talking about, whichever organization you are talking about, these 5 parts will put you firmly in the business driven architecture model. Only one paradigm is promising in this area, that is object oriented analysis and design, holds a very high promise in the area of business driven architectures, which translate to requirements driven, and with UML becoming a dominant aspect in the entire exercise, it becomes use case driven software development, software architecture. So, based on this we use OAD. Very quickly we can talk about objects and object oriented analysis and design. What is the promise that we are holding on? It is not merely change anymore, extensibility both in terms of componentization as well as services. It does both, object oriented does both. However, the service oriented architectures in 2 forms, web services and the cloud computing kind of services, they have dominated this past few years. Wherever we go, it is there. Now, once they have reached a summit, once they have reached a peak, we can always fall back to what is called object oriented, and in the next wave of what we are calling Internet of Things, it is very likely that object oriented analysis and design with common object request broker architecture will dominate. It works with components, it works with services. Then what is the problem? The problem is, what we are promising is software functionality extensions. So, we talked about certain things called direct components, certain things called indirect components, services, direct services, indirect services. So, this is a corresponding figure based on which we are talking about activity category, systems, envisioning opportunities, system scoping, understanding needs, goal. So, what is the point here? The point here is Chris Partridge's book clearly tells that this kind of a context will nicely translate into life cycle planning, feasibility evidence, negotiating commitments, development of evolution. It is not that we are simply trying to cross hurdles or put hurdles. It is understanding the business context, which is like this. It must be translatable into this kind of an idea: monitoring and control, operations, maintenance, organizational capability improvement, software paradigm shift, productivity. The productivity is a paradox. That was the number one lesson which we have been learning. I did some good simple case studies through what is called the Capper-Jones statistics, Capper-Jones metric. If you say that you have proficiency in C programming language, MCC, that is, you are expected to develop 60 LOC per 8-hour working day, which means 7 LOC in 1 hour, 1 defect included, 1 defect 1 hour. So, what we did was we started looking at productivity. However paradoxical it may sound, based on certain simple metrics, we simply said that object oriented and component based development, these are the two ideas that are clearly showing rapid advances in improving the productivity of software development. The software paradigm shift pays well at this juncture. It pays very well, but then that is at a higher complexity, UML, ADL and so on about it. The agent based development is also there. It is one of the pioneering ideas. We talked about software agents. They are also related to components. So, whether we like it or not, certain waves on service oriented architectures have happened, but as we are progressing, we are absolutely clear that it is agent based, and the second one is the Internet of Things. These will be the two prime movers for making object oriented stand for another 10 years from now. Another 10 years we will talk about, it is not a specific language, it is about a paradigm, an object oriented paradigm that began in the realm of programming languages. No doubt languages will come, languages will go, we talk about many more language comparisons, we talk about lot of heated debates on which language to choose, but however software agents and Internet of Things, these are the two dominant ideas which we think will happen, carry forward for next 10 years. This idea gave lot of fillip to component based in 2005, until now it is holding. Internet of Things is added to this, will have a stretch of another 10 years. So, this is where we are talking about. In summary, object oriented allows us to focus on the value. 30% of software development effort is spent on infrastructure that adds no value. Application specific, they are called business issues. Standard reusable parts is on the infrastructure. So, what we are calling as infrastructure? GUI, communication, data model, deployment, that is all shared, and we should understand where to draw a line, where to draw a contract, where to define a service, where to define a service level agreement. So, the challenges are still ahead. The business issues become very clear, either they want reverse engineer, forward engineer or re-engineer. Once that is done, the standard reusable parts will make object oriented analysis a very valuable paradigm for what we are expecting in the next 10 years. Thank you. We will meet in the next lecture.